All right, wizards. So here's another problem that we was on the MyOpenMath from today. This is the second problem, and we're actually going to do this problem in two ways. So in this first video, we're going to approach this problem from a confidence interval point of view, and the question we want to answer is, can she conclude that more than 60% of employees at the company are satisfied with their jobs? So we're going to try to answer this question, I said, in two ways: from a confidence interval point of view, and on the next video, from a hypothesis test point of view. So first things first, let's check our conditions for using a confidence interval in context. So the first one, 100 employees were chosen at random, and it says so in the text above. In the sample of 100 employees, it said that 64 of them said they were satisfied, which meant that 36 were not satisfied or something other than satisfied. And since both of those are greater than 10, our sample is large enough. And that means large enough to use a normal model in this situation. And the third condition is we want our sample to be certainly big, but not too big. So 100 is, we're going to assume less than 10% of all working adults, which is where our 60% population proportion came from. So the conditions seem to check out. Since our conditions check out, we'll continue. So the model that we are using, we are going to use a normal model, but we're going to use our normal model and we're going to build it with our p hat. So the p hat is 0.64 and the sample size is 100. So that's the mean of my model, and there's the standard error. So the standard error of my model is there. And I'm using 0.64, the p hat, the sample proportion, to create that normal model, which is why I refer to it as the standard error. Now construct a 95% confidence interval, show your plus minus step, and then show the confidence interval using interval notation. And here is my plus minus step here. And this is my p hat. That's the special z-score. And this is the standard error. And when I work out the subtraction problem and the addition problem in this, my interval, the lower bound, is 0.546 and my upper bound is 0.734. So that's my 95% confidence interval. So the question that we want to ask is, can she conclude that more than 60% of her employees at the company are satisfied with their job? Well, we can't do that because our confidence interval in this case, our confidence interval was 0.546 as a lower bound and 0.734 as the upper bound. And 60% is inside that interval. So since 60% is inside the interval, it's actually a plausible value. So for example, if our interval happened to be like this, which means 0.6 is outside of the interval, then we could say yes, our interval suggests that more than 60% of employees are satisfied with their job. But in this case, we cannot say that. And if you were to interpret your confidence interval in context, what I would say is that I am 95% confident that the true population proportion of employees who report they are satisfied with their jobs is between 0.564 and 0.734. And if I were to explain what 95% confidence means, if I repeatedly took samples of size 100 from the same population, approximately 95% of those samples would produce confidence intervals, would lead to confidence intervals that contain the true population proportion. So explaining what the confidence interval means is about my method of creating confidence intervals. And the last question, without changing my p hat, describe two different ways to make the interval wider. So right now my interval is not quite 2/10 wide. So how could I make it wider? Well, one thing I could do is I could increase the confidence level, but leave the sample size the same. Don't change the sample size, just make my confidence interval larger. Or I could leave the confidence interval the same and make my sample size smaller. So those are the two ways that you could make your interval wider. So that was the confidence interval approach. Again, play this back as you need to, and pay attention to the interpreting your confidence interval, explaining what confidence means, and can we make conclusions based on our interval? And then the next video, we'll do the same question again, but we'll use a hypothesis test approach. So that's Wizards. I hope this video has been helpful.